For those of you that don't know me, my name is Brian Voigt. I'm a research assistant professor in the Rubenstein School and a fellow at the Gun Institute. And today I'm going to talk to you about one of the focal points of my research, which is using computers to construct simulation models of coupled natural human systems in the world around us. I like to think of this as video games for adults that like science and math. I explored data depicting the physical, natural, and socioeconomic components of an area of interest to build a mental map of what I see. If I translate my mental map into computer code built on data, evidence, and equations, and this is commonly a process that happens in conjunction with stakeholder groups who identify key issues, potential solutions, and likely obstacles to implementing actions for mitigating or resolving those problems. And I use these simplified representations of the real world to explore policy, management, infrastructure, and climate-related questions using scenario analysis. So first, the mental map or conceptual model. I use the development of this conceptual model as an entry point into learning about and hopefully understanding the finer points of the system under investigation. Who are the actors involved, and who are we concerned with? What are the driving forces, again, social, economic, and natural, that influence outcomes and lead to changes in the status quo? What are the primary natural systems what are the primary issues, and do we have the means to influence these to achieve our desired goals? Stakeholder groups are a key component of the participatory modeling process, and they present both opportunities and challenges. Opportunities in the form of soliciting input and feedback, accessing data and knowledge, identifying desired future conditions and the obstacles to achieving them, community priorities, and political landscapes, among other information. The challenges always lurk just beneath the surface as different stakeholder groups vie for sort of the prominence to convey that their intended outcome is the outcome and everyone else should respect their wishes. It's also really important to think about the fact that we can use the local knowledge of the stakeholders, their expertise, to contextualize the system that we're studying, but also from a standpoint of achieving buy-in from the local community. We don't need everyone to be an expert in Bayesian modeling like what you might see here, or agent-based modeling for that matter, but we do depend on their knowledge to help inform model development and application. We use these inputs to craft the model itself, which can be something like the spaghetti monster you see here in a visual modeling environment, or much less interesting to look at, just simply writing computer code, connecting databases, and conducting spatial analysis. Now, as you might expect, spatially explicit models rely heavily on contributions from quantitative spatial analysis. There are a number of different software options that offer the experienced user an opportunity to extend beyond the out-of-the-box software functionality. One of the things that we see here is a customized tool built for ArcGIS that allows users, non-expert GIS users, to interact with the software and compute results for their own area of interest, all the while based on the underlying technologies and analyses that are not necessarily approachable to a lay audience. So all of these different tools build up to the ultimate goal of scenario analysis, where we can impose some sort of alternative condition on the baselines, such as policy, land cover, or demographics, to yield a different set of results, and essentially building this envelope of possible futures based on all the different possible policy and other alternatives that folks are interested in looking at. And I'd like to just point out, I've done this for a number of different projects. First of all, looking at freshwater ecosystem services in Tanzania and its relationship to economic livelihoods and the spread of infectious disease. Used a different model and a different modeling platform to model land use change in Chittenden County with a wide range of collaborators to look at infrastructure and policy alternatives and the effect on land use outcomes. And then finally, modeling the effects of minerals development on recreation and groundwater as part of a project with the Bureau of Land Management. And so what we see here is sort of this window to the past, a window to our geologic past, that slowly and over time the iconic views of places like Arches National Park are seeing more and more types of development that could impact the recreational experience and the ultimate economic viability of some of the communities that support it.